Thank you for the purchase of my DVD. Included on this DVD will be a 600 line Western Electric step system, a 200 line Stromberg Carlson step system, an 80 line North Electric CX100, and a 400 line Western Electric No. 3 crossbar. In addition to that, I do have an automatic electric sat system that is not assembled and is not presented on this segment of the DVD. I am currently standing inside of my telephone display room that contains approximately 300 single-line phones. I also have another room under construction that will contain approximately 300 multi-button key telephones. The long-term plan is to have each and every telephone with its own dedicated number off of one of my switching systems. Included on this video is a short segment on a 3CL switchboard and a toll test board. Also, I have one central office mainframe that will be separate from the rest of the videos because it's a combined frame that is not specific to any one particular switch. Again, thank you for the purchase of my video and enjoy. I have spent many thousand hours assembling the switching equipment, refurbishing the phones, and trying to make the entire system work. Still have approximately 4 to 5 years left to complete the entire project. We're currently looking at the vertical side of the mainframe. This is a 10 vertical mainframe. Of course, it's 9 foot tall as well as the switch frames. We're looking at all of the cable that is coming off the cable rack down onto the vertical arms to their blocks. All of the cable on the mainframe, the horizontal side and the vertical side, all drop off on this side and are then ran down to the correct location or block. As we're looking at, there's a massive amount of cables. Most of those are 100 pair cables or 50 pair cables. Alright, we're now looking at the vertical side of the mainframe. We have our protectors. Every single customer's telephone, when it reaches the central office, is connected to what's called a heat coil. It's a lightning protector like a fuse. Of course, here I have several hundred pairs, and these are protectors that's going to my key system or to single line telephones in my display room. And then here we have miscellaneous blocks. These are the more modern blocks that's currently being used today. This block can mount on the horizontal side or the vertical side. And of course we have the remaining blocks, and there's many hundred jumpers on here because my selector levels for the trunks, such as the camera trunks, the dial 9 trunks, the 0 trunks, they are done on this side, and on the other side is just the connector, numbers, and the line equipment. The line equipment then is of course jumpered over to the protector. So when you're running a service order in, every telephone number has two jumpers. A jumper between the line equipment and the connected terminal, and another 2-conductor jumper from the line equipment to the cable pair that would be going into the underground or aerial cable into a customer's home. And again, like these are trunks and so forth. And this is just a normal mainframe, and it's still very used in all modern applications except for the voice over IP, which is a different concept. This particular mainframe is a kind of a super combined mainframe because I have my Western Electric equipment terminated on it, the Stromberg XY, tie cables to the number 3 crossbar switch, and also cables to the automatic electric equipment, which will be eventually the AE SAT system, and the AE local equipment will be in one building, and there will be tie pairs from this frame to the SAT system. Okay, we're looking at a small segment in a central office main distribution frame. These here are the terminal blocks and the connector shelves. Down here, of course, are the terminal blocks from the line equipment, such as the line group number 1. Each connector has a 3-conductor jumper from the tip ring sleeve that would run from a connected terminal to any line circuit. This is where the phone numbers are tied to, and here's the line circuits. There's no correlation between a connected terminal number and a line circuit from a numerical standpoint. Any connector can be connected to any line circuit, and vice versa. This connector group is the 5200, so if you use to dial 37752XX, there's 4 blocks that would have 100 telephone numbers on it. The main frame is, of course, 9 foot in height and approximately 7 foot in length from left to right. And there's over 150 to 200 blocks on this frame. There's approximately 100 on this side, and then on the other side, 60 or so blocks, as well as the protectors, which would be the customer's telephone would be connected to that outside plant stuff. This is a normal mainframe. In today's modern world, they do not use this particular type of connecting block, but the mainframe is still the same, and they've been around since basically the turn of the century, and there really hasn't been any changes in the mainframe from a structural standpoint. This is a Lorraine 100 amp 48 volt central office rectifier. This particular rectifier is offline and has been replaced by some Northern Telecom 25 amp per module rectifiers. This is a ferroresonant rectifier, and these are switching mode rectifiers. In the idling mode, the central office is drawing less than 13 amps of power. When I turn on the traffic generator, then I will exceed the capabilities of one rectifier, thus meaning I need to turn on the second power supply. Under a normal day-to-day operation, one rectifier carries the load without any trouble. When the number 3 crossbar system is turned on, just to give dial tone for a subscriber line off the number 3 crossbar is about 12.5 amps. When you go to complete a call within the crossbar, it's about 10 or so amps to complete the call. If the call is external to the crossbar, then of course it uses what is called a sender, and during the call setup time, I have seen the total amp load exceed 30 amps between the step and the crossbar. Here is a close-up of one of the Nortel 25 amp modules. We're currently looking at the power distribution. Each one of these fuse blocks is running to a relay rack or a switch frame. This particular power distribution is for the Western Electric step-by-step, the CX100, as well as the Western number 3 crossbar system. These particular fuses here are the power for the 3CL switchboard. We're currently looking at Type 70 fuses. This particular set of panels here each fuse is wired to an individual device, such as an outgoing trunk, incoming trunk, tone to pulse converters, or any peripheral equipment that would need a fuse of up to approximately 5 amps. They do make fuses for these 70 type that are up to 10 amps, but in my particular application I do not exceed 5 amps on any individual fuse here. A type 70 fuse looks such as this here, that if the fuse was to blow, this would pop out and provide an alarm indication to alert the local switching people that there was a trouble in a particular device. Then they would be looking in a book and find out which particular fuse, what it went to, and then they would start working on the trouble there. These things that look like light bulbs are actually called ballast lamps. They're in the circuit and there is current flowing through them, and under a normal operation they would never light up. However, if there was a excessive load or a short, these would light up and would, instead of blowing the fuse, would light up. And of course there's a record of which each ballast lamp, what they're doing. In my particular configuration, these are all ringing lamps in series between the crossbar and my ringing plant here, as well as the step-by-step and other peripheral equipment. We're currently looking at the central office interrupter. This is a dual ringing tone and interrupter plant. Currently the lower interrupter is operational. The function of an interrupter is to take a continuous source and interrupt it either at 120 interruptions per minute, 60 interruptions per minute, or the different ringing cadences that you would normally encounter in a step-by-step central office. If this interrupter was to fail, through these transfer relays, the top interrupter would take over automatically and then would perform its same function. And then of course we would have an indication up here in the top that we had an issue. Currently I do have it transferred because of a couple of issues in the ringing plant. Down here where it says tone generator, we have two tone generators that produce the dial tone and the continuous tone that is then fed to the interrupter. The dial tone feeds the first selectors, and then of course the tone, in addition to that, feeds to these springs on the interrupter, so that you have a busy signal or an overflow signal such as the 120 IPM signal. Also down here below is an inverter. If the AC power fails, this is a motor that is operated in 48 volts DC, which then starts up and operates a generator, which then the relays transfer. Everything still operates on AC because of the generator generating AC from DC. This of course draws a tremendous amount of amp current and would run the batteries down fairly quickly in my particular application. But this was a normal configuration in a Bell system step by step. This is a model 806F, as in Frank, ringing plant. We're currently looking at the ringing generator. This produces 105 volts at 20 hertz, which is a continuous output, which is then connected to the interrupter to give you the ring cadences. This particular ringing generator, as well as this one, is the redundancy, provides positive and negative superimposed ringing. So for party lines, 4-party and 8-party lines, this would be the correct ringing plant. We're going to show you what a step-by-step line finder looks like and how it functions. In the particular central office that we are standing in, the Western Electric 355A machine is 600 lines, which means there's 20 line finders in this particular configuration of line group here. So we have 200 line and cutoff relays, 20 line finders, and then above it, of course, is other types of switchgear. When a subscriber wishes to place a telephone call, which is connected to their telephone is connected to a line circuit, so when they go off hook and get a line finder will go and look for the line and give them dial tone. Currently we have dial tone, which is coming from the first selector, so this particular line finder is hardwired connected to a first selector, which is located in a different aisle of the central office. we have turned on the test routine of the line group. I have removed the can cover to expose the line and cutoff relays. Every telephone subscriber has one pair of relays, a line relay and a cutoff relay. The function of a line relay is to provide 48 volts battery and ground in the idle state towards the subscriber telephone. When the subscriber removes the handset on their telephone, that causes current to flow to operate the line relay. When the line relay operates, that then causes a group relay to start the line finder. The line finder will hunt for the line, and once it finds the line, then it will cut through to the first selector. Upon cut through, the cutoff relay then operates, which is here. So the line relay does not have a long-term involvement in the initial call setup. The cutoff relay will maintain operation until the end of the call. Also, the cutoff relay is used for the connector to complete through when it is terminating a call to that line. I have a central office test set which emulates a telephone for this particular presentation. Each group circuit, which is controlled by 10 line and cutoff relays on one strip and an additional 10 further down in the line group, causes a line finder to operate. The line finder has a preference chain out of all 20 line finders. So the lowest numbered finder for that group circuit will then be used. If that finder was busy, then it would go to the next one and the next one and so on until all finders were busy. We're looking currently down aisles 102 and 103. This is 102 and this is 103. There's, in this particular lineup of equipment, which is 18 foot long, we have several 23-inch relay racks and one 19-inch relay rack. And then over on this side we have 3 switch frames. The switch range from one end to the other is 6 foot by 9 foot tall. This particular type of office, which was a Model 355, was quite common to be in a 9-foot environment, which would be 9 foot from the floor up to the ironwork. Currently in this bay, which due to the configuration, it is difficult to get good close-ups of all the equipment. In one relay rack we have O carrier, which is open wire carrier. Then we have the ringing plant, which we talked about already. Then we have small line groups, which is connected to the coin trunks, prepay coin trunks, as well as dial tone first coin trunks, which this entire bay is all related to coin equipment. Then this bay here has alarming equipment, interrupter stuff, as well as just miscellaneous types of test equipment and private line stuff. Over on this side of the aisle we have a 200 line lockout line group, which this particular line group I estimate weighs about 700 pounds fully loaded, and was very difficult getting it in here. Each subscriber has 3 relays, a line relay, a cutoff relay, and a lockout. The function of this line group was if you had a cable or open wire that had multi-party service on it, if a subscriber was to remove their handset and leave it off the hook for a period of time, it would lock out the line and release the line finder. Well, that concept is if you had an open wire and a tree went across the line and took out several pairs of open wire, that way when they would draw a dial tone, because it would look like an off-hook condition to the step switch, after a period of time it would lock those lines out and free up the line finders for subscribers that were not affected by damaged cable, wet cable, and so forth. Up here above the line group is my test distributors connected to a test cabinet, as well as the operator is able to dial in and listen in on the line, break into the line. So that is being done through these test distributors. Then on the next line group, which we showed pictures of a line finder working, is the second line group in the office. And then we have operator trunks, incoming trunks, and outgoing trunks that deals with intertoll as well as local facilities within this exchange. And then, of course, I have selectors and connectors and more connectors, which we'll talk about further on in this part of the video. We're currently at the other end of the aisle looking back because of the aisles being 18 foot long, and there's only 32 inches between the face of the aisles. Again, it's very difficult to have a very good video. Again, we're looking at the second line group with 200. This is actually line group number 1 with 20 line finders, and there's 200 lines in that, as well as miscellaneous selectors for special functions. And then, of course, we're back at the bay of e-signaling, which is connected to the O carrier. This is the SF stuff, which we will talk about on the carrier portion of this, as well as there's private line ring down trunks and so forth. Currently, you hear operating in the background relays going up and down. That's repeating pulses from the interrupter for timing for other equipment, as well as alarm stuff. I have it providing ground pulses to control some of the ringing, which is done on the mainframe for the 4-party and 8-party phone lines. In here we have the interrupter stuff, we have the central office alarm panel, and then we have other distribution equipment. The central office alarm panel, if I was to have a blown fuse, would ring a bell here as well as operate my main chime. And I will demonstrate that here in a moment. Then we have in this particular aisle just more support equipment. This entire aisle of the bays is all peripheral equipment, incoming, outgoing trunks, alarming, and miscellaneous stuff that you would find in a normal central office. The one small variation about this office versus a normal office is I have built this to be a very high traffic central office. So if you were in a very small community, you would not have as much peripheral equipment normally in an office of this size, because a 600 line office, if you were to take all of the equipment frames in here, you would have approximately an 80-foot long aisle of equipment, approximately 9 foot tall. I will put in a blown fuse. This is a type 70 fuse, which has been blown on some testing and so forth. Anyway, the little tab pops up, which then connects 48 volts to a common bus, which is, the common buses are all tied to relays to the office alarm system. And you'll hear the bell as well as my bong alarm in the background. I've silenced the ringer in the alarm system, and you hear just the office alarm in the background. Anytime that any equipment ever has a short issue, it would blow its associated fuse, which would then bring in an alarm so that the technicians would know that something's wrong. When I put in a fuse that is blowing, we'll operate the fuse alarm and then light the light on the shelf. This light, of course, is only for one particular shelf in the central office. Well, we just showed you what happens when a fuse blows, where it lights up a fuse alarm. If one of the step switches was to be stuck in a level in the bank, after a period of time, it would light up the green light, of course, showing that's off normal. And after a period of approximately 1 minute, I believe, it would bring in a major alarm. And of course, the green light is indicating that a switch is held up in the shelf. This particular shelf has 10 switches, so of course the technician would have to look at each individual switch to determine if there was a legitimate phone call on it or if the wipers were stuck in the bank. We're currently looking at the first selectors. I have 60 first selectors in this office because I have 60 line finders. Each first selector has its own dedicated line finder. So in the case of this one is selector number 25, 26, 27. It's also going to be connected to the line finder. Now in the line group number 2, line finder number 16 is connected to first selector 26 because there's only 20 line finders in each line group, but I have 60 first selectors, so my first selectors are numbered from 1 to 60. So line group number 1 is connected to line finder 1 through 20. Line group number 2 is from selector 21 through 40, and so forth. I will go off hook and you will hear dial tone, and dial tone is actually originating from the first selector. So any digit I dial of 1 through 0 will be dialed in this switch. For this particular demonstration, I would dial a unused level, which would be number 8. You're currently listening to 120 interruptions per minute IPM reorder tone. If I was to dial a digit 3, because the office code here is 377, I will dial a 3 and it'll step up to the level number 3 and will land in the first terminal. Currently I'm sitting on the 4th selector, which is on the next switch frame over, which we'll show in a moment. This particular selector is only being utilized for single-digit dialing. It does have the ability for digit absorbing, but in this particular function, it's only operating as a single-digit switch. So since I have dialed a 3, I am now on another switch. If I was to dial a 1, I would reach a camera trunk, which would be connected for long-distance toll dialing. Or if I dialed 0, would ring in on my 3CL switchboard if I had that operational. And at this moment it is not, but it will be in the future. If I dial 9, I would reach an outside line, as well as any of the other digits do wire to different things. This particular exchange has 6 office codes in it. The primary office code is 377, which is for the Western step-by-step. And then the 462 into the XY, 543 to the number 3 crossbar, 448 to the CX100, 367 to the AE step system, and then 668, which would go into the iTech EMS 1 or 2, depending on which thousands group you dialed after you dialed 668. Alrighty, we're now on the 4th selector. We've already dialed a digit 3 in the first selector, which I am now currently connected to this selector switch, which is an intermediate selector. I will be dialing 7-7. It'll be absorbing each of the 7s because this is utilizing the digit absorbing functions for the 377 code. So I'm going to dial first 7. The switch went up to the 7th level through the off normal post here, released it. So if I dial another 7, I can dial 7 forever, and that's the only function that will happen when I dial 7. If I dial a 5, it would then cut into the 5th selector. We're currently sitting on the 5th selector, which is in a different switch frame. We have in this particular office again 60 4th selectors. So of course, there's the larger the central office, the more equipment. Due to having 5 EAS prefixes as well as the home prefix of 377, as well as 60 links, it requires a very large amount of equipment. This is a 600 line office. If you was into a 20,000 line or a 40,000 line step office, you would have a building that would literally be a city square block, multiple floors of switching equipment for the toll equipment, the local equipment, power, and so forth. So this was a great concept that AE had developed and had went big with, and then of course Western Electric bought the patent rights or licensing rights to manufacture the Stroger switch for the Bell system, and there was millions and millions of these manufactured, and of course in basically 1995 the last step office that I knew about was retired. So you can imagine the size of the operation. We do have a traffic generator that we will turn on shortly that will generate approximately 20 to 23 phone calls at a random order to give you the feel of what a real legitimate central office sounded like in its original day. We're currently sitting on this switch, which is the first switch, of course, on the shelf because there's no traffic in the central office. If this particular switch was busy, then I would have received this switch or accessed this one and this one, up to 10 of them on a shelf. We've already dialed 3775. Of course, I demonstrated that we believe dial 377775. So I will have the choice of 5100, 5200, all the way up to 5000. So I'm going to dial, for an example, the central office number, which would be a 500 group. So it will be 5500. I'm currently sitting now on a connector shelf, so the switch is stepped up to the 5th terminal, and we'll show the connector in a moment. If that terminal was busy, if there was another customer that would have dialed a 5, then I would have reached the 2nd connector, the 3rd one, all the way up to the 10th connector. Alright, I'm at a different connector, which is easier to get a shot of. I'm going to demonstrate a few things. Unlike a line finder and a selector, the connector is the last 2 digits of the phone number. Previously, we dialed 377-5555, which rang the central office telephone number. I'm on a different connector shelf because I have 8 connector shelves, which would be 8 different groups of 100 numbers, and this particular shelf is the 5600 group. I'm using a telephone test set which has got a special connector to plug into the switch. So I will simulate dialing the last 2 digits of a phone number, but in a normal situation I would have had to dial 5 digits prior to getting to this switch. So I'm going to dial again a 5 and a 5. So I stepped it up to the 5th level. I'm going to dial 5 again, and it'll step it over to the 5th terminal. So in this case, if I would have been on the black phone that we were using for the demo, I would have dialed 377-5655. If I was to dial 99 in the Pacific Northwest Bell Territories, that was always a busy number, so that when the remote testing was done, they could dial 99, and as long as the dial pulsing through the toll network as well as the local switch train was correct, they would reach a busy number. If I was to dial 11, of course, I step it to the 1st level and then to the 1st terminal. Now, the connector provides the ringing generator towards the customer's phone, as well as it couples a ringback, a capacitor, so the customer can hear ringback tone coming from the line that's actually being rung. This particular connector is kind of unique. It is a 10-party connector, and it has a tip and a ring and a sleeve and a control lead. The control lead is wired to some auxiliary equipment, and how the wiring is done at the mainframe as well as a pulse coming out of the interrupter, you can ring 5 parties tip to ground or 5 ring to ground and have a 10-party line. We're currently looking at the rotary line group that is used primarily for coin telephones. These line groups also had other functions. They could be used as a trunk finder, such as a vacant level to a intercept trunk to an operator. Primarily, I've always seen them used as just miniature line groups for pay stations. You have 3 strips of 7 line and cutoff line strips. So this is a 21 line group. We're currently looking at one of 5 coin trunks. These were one of the last generation wire spring coin trunks that Western had built. This particular trunk is a deluxe trunk, as in it has a mini register in it to allow you to dial 911 without a coin, 0 without a coin, or certain toll-free numbers. You have the ability to program these, very limited of course, in order to allow certain what was called coin-free access. However, on local calls, of course, you had to deposit a coin in the payphone to satisfy the coin trunk that a deposit had been made. One note is the coin trunk does not have any way of knowing how much of a deposit was made. The telephone itself has on it what is called a totalizer circuit, and once the totalizer was satisfied with the deposit, then it would provide a ground on the tip side of the phone line that the coin trunk would look at to verify if the coin had been deposited or not. In this configuration, these are connected to their own individual line finders, and then they have their own first selectors. The line group that I currently have is only 21 lines, and it is a complete rotary line group, as in it does not have a two-motion switch. It just has one single rotary switch that's used as the line finder. Alright, I'm going to make a 1+ call, and when I dial 1 I will land on this particular trunk. This is a CAMA trunk, which stands for Centralized Automatic Message Accounting, which is the billing part done in the toll office. This trunk is part of a system called an Automatic Number Identifier Type D. What just happened is after the 10 digits was dialed into the tandem office, it requested the number that I was calling from. The number I dialed, of course, is busy. And this trunk would be held up for the entire duration of the telephone call. Alright, we've got kind of a long view of this aisle. Of course, there's 8 relay racks in this particular aisle. This is the 101 aisle. From here down for the next 3 relay racks, this one, the next one, is what's called an Automatic Number Identifier Type D as in Delta. In this particular bay, there are 10 trunks. This bay are 10 trunks, and so forth. When a subscriber makes a long-distance 1+ call, they would access a trunk, depending on how the wiring is done at the mainframe and the selector level, and they would be using one entire trunk for a duration of a phone call. These are what's called super trunks. There's 4 different accesses to that trunk: 1+, 1+ coin, 0, and 0 coin. So these are kind of a high-end trunk. In a normal A&I type situation, you would have a bay of coin trunks, a bay of normal 0 level trunks, and then of course your 1+ DDD trunks. CAMA, of course, stands again for Centralized Automatic Message Accounting. This would normally be connected to a crossbar or a number 4 ESS machine, which would be recording the number of digits dialed, and then after it was satisfied with the quantity of digits, it would request from the ANID the number that the call is originating from, your telephone number. The toll office would then put the call through, and then would take and either punch on a paper tape or put it onto some type of electronic medium the destination number and the number that you call it from and the time of the call, the trunk number, and so forth. Just when you hear the ANI out pulse, it is sending in MF tones the number that you're calling from. When you make a long distance call, you're sending dial pulse to the toll office. When it requests the ANI, that is done in an MF format, which is a 2 of 6 format. I have approximately 40 CAMA trunks. In this particular setup, we are going into an asterisk system that has been configured as a Class 4 toll switching system. So it can emulate any particular type of a network call that I want to make, either call through the normal PSTN or a VoIP call through the collector's network or back into myself. The call I made previously was a call from myself to myself, just to demonstrate both ends of the phone call and how the A&I work. This is a fairly complex system, and there's only 3 or 4 of these that I know of left in the United States that is a wire spring version of an A&I. Now, of course, Model D meant they had an A&I C, A, and B. The A and the B were all flat spring relays. These are, of course, wire spring relays. We're currently looking at what is called a 7A announcement machine. This is the machine that would be accessed if you dialed a number that was disconnected or a level that was not currently in use.
The number you have reached has been disconnected or is no longer in service. If you feel you have reached this recording in error, please check the number and dial again.
We're currently looking at the tone to pulse converters. These convert the touch tone into dial pulse for the Stroger system. Alright, we have a traffic generator running. You can tell there's a fair amount of traffic in the office, and this would be a normal for a central office of this size. So we'll give you a little bit of audio sound here. We're currently looking at a Stromberg-Carlson XY step-by-step system. Stromberg, of course, was one of the leading manufacturers. You had Western Electric, Automatic Electric, and Stromberg-Carlson were 3 major equipment providers in the United States, as well as North Electric out of Galion, Ohio. This is a common equipment board. We have vacuum tube tone generators. And we have our working and redundant, so A2 was to fail, there's monitoring circuits monitoring the dial tone. We take a continuous tone from the tone generator and feed it to the interrupter, so you would have the same tone for your busy and reorder as you do your dial tone. And if we was to have a fuse operator, would bring in a fuse alarm letting us know that there is an issue in the central office. We're currently looking at the interrupter. We have the primary interrupter, the standby interrupter, and then of course this is currently my ringing supply. This is a vibrator tuned forks which are taking DC and they're interrupting and making a pulsating DC at 20, 30, 40, 50, and 60. Currently have a 20 hertz, 30, 40, 50, and 60, and we're using the 20 hertz to provide ringback at the connector. The interrupter right now is of course interrupting each of these frequencies, and there's a marking lead which is coming from these relays to synchronize the ringing of this device with the particular telephone number you dial, because I can have 10 party phone lines, 5 frequencies on the tip side, 5 frequencies on the ring side, and the ringing is all being done in one lead. So they're sending pulses out, or a pulse out, in conjunction with the ringing, and depending on the mainframe, what I tie down for the ringing code will determine which frequency is run at that particular moment. We're currently looking at the XY switch itself. This is a universal switch. This switch can be used as a line finder, a selector, or a connector. Depending on what the end of it is plugged into would determine what the function of the switch is. If this was being used as a selector and a subscriber was to dial a digit 5, for an example, you would step this switch over to the 5th position, and then it would automatically on its own start looking for a vacant path to the next switch or a trunk. Then you would be connected to a like switch on another shelf if you was accessing another selector. If you accessed the trunk, it would only be this device plus a line finder. At the end of the telephone call, when a customer hung up, the switch would return to home position. And then, of course, that link is ready for the next customer to use. I have an XY switch mounted in a test box. This was an item used for adjusting the switch and checking the speed. I will let it step the X direction. Now the Y. We're currently looking at the bank blocks of my 5th selector shelf. This is shelf A and shelf B in this configuration. And all of the levels and trunks off of each bank, this particular set of switches accesses this bank, this particular set of switches accesses this bank, are all wired. In this case, we have very limited wiring out of here. These are of course, the 5th selector, so I have the 6100 group for the connector shelf 1, and then the 6300 group for connector shelf number 2, and the remaining terminals are all strapped out to ground, so if you used to dial a 6.4, 6.5 or whatever, you would just get 120 IPN reorder time. We're currently looking at the line group. This is a 100 line lockout line group, which means each line has 3 relays associated with it. We're going to be connected to these 3 relays right here. So when I go off hook, we will operate the line and cutoff relay. Also over here is some of the control relays for the lotter and the line finder. And each XY switch has got an additional relay, which is used for stepping the lotter and operating the line finder. So I'll make an on-hook, off-hook condition. I'm currently off-hook right now, as you can hear in the background the dial tone. Each time that I hang up and go off-hook, I get a different line finder, and once I hang up, it steps the lotter to the next line finder. And you can see other control relays operating. And this is set up that if one lotter is in trouble, then the other one will be operational. And then of course it has the alarming relay and so forth. We're currently looking at the first selectors on my XY system. I have 21st selectors because I have 2 single 100 line groups. I'm currently plugged into this selector switch right here with a test set, and I would dial the office code, which is 462. I just dialed a busy number, so I've gone from the line finder to the first selector to a fifth selector into the connector switch, and of course on the other selector I was doing a digit absorbing. On the first selector here, of course, we have level 1 for toll to the camera trunk and level 0 to the operator, and then the remaining digits are used for EAS calls or intra-system calls. This particular exchange, of course, is wired to my Western Electric step-by-step, which is 377. In this case, I am doing digit absorbing on the digit 3 on this particular shelf right here. So depending on the office code dialing, the digit absorbing is being done in different parts of the office due to the massive complexity of this particular exchange. We're currently looking at the connector shelf. I have two shelves of 10 connectors. And this is where the last two digits of a telephone number would normally be dialed. This is, of course, a TPL office, so I would not have a third digit in this particular device. Some central office connectors would have 3 digits, and they'd have additional components in here. So I'm going to dial a digit of 9, 6. And of course the relays were following the digits I was dialing. The light is letting me know that I've accessed that switch. And if a customer was to answer, the light would go dim, letting the technician know there was a legitimate phone call through that part of the equipment. This is the back of a connector shelf. I'm showing you what the back of a wire bank on a Stromberg XY looks like. In this particular case, because it is a connector, that is a 2-digit switch. If a customer was to dial, for an example, 50, the switch would be stepped over to the 5th location, which would be technically a level, and then the last digit, the wipers, which is not able to easily be seen, would step into the bank. These very particular wipers here, the most closest to the camera, would be the 11th terminal. So if you dialed 50, it would be the 5th level by the 10th terminal. If, in the case of a selector or a line finder, depending on how it was set up, you may be forced to the 11th position as a blocked call. Generally, you would not be ever on the 11th position. This particular piece of equipment here is an automatic number identifier. The purpose of an automatic number identifier is when a customer makes a long-distance telephone call, they dial, of course, 1 plus a 7 or a 10-digit telephone number. The telephone number is being dialed into the tandem office, and at the end of the 7th or 10th digit, the tandem machine then requests a ANI from the end office. This particular equipment has a pulse generator that produces a high voltage pulse that is sent through the trunk, through the selector, and then through the connector terminal, because the line terminal and the connector terminals are tied together. That fires a neon lamp on a printed circuit board, which I'll show in a moment, and that neon lamp will only 1 out of 1,000 or so will operate. That sets the logic circuit in the outpulser to send the number that the call originated from. Stromberg had a unique feature for multi-party service. They had what was called an option that could be wired into the system that would require a party digit to be dialed after you dialed 1. For an example, you would dial 1 plus your party digit of 1 through 0, which did not have to correspond with the last digit of your phone number. It was an arbitrary digit that the phone company assigned to each line. Then you would dial your 7 or 10 digit toll number. When the far end, the tandem office, requested the identification, then they knew which party of a multi-party service that the call was originating from. So as far as the toll office was concerned, it was a non-party line type call. In the Bell Systems equipment, they did not use that feature, so when a person in a Western Electric office would dial 1 plus a toll call, if they were on a multi-party service, such as a 4-party or 8-party, the operator would have to come on and ask for the number that you were calling from. That was an expensive, time-consuming task. With the Stromberg XY, they eliminated most of that with the circle digit. It was a pretty neat concept, actually. Here's a close-up of the neon lamps on the matrix card for the Stromberg identifier. We're currently looking at a North Electric CX100. North Electric was one of the smaller manufacturers of telephony equipment in the 40s, 50s, and 60s. And they had one really neat product line. They had several different products, but one of them was the CX100, CX60, CX30, and then of course they had a CX1000. This was a 100% relay controlled system. Unlike a Stroger step-by-step and a crossbar type of a system, this used multi-contact relays, which is currently these items here, to accomplish the same thing as a crossbar on a cross point would, or the equivalent of a bank and wiper configuration in a Stroger system. This system is a very quiet system. You could actually have this in your house in the front room and watch TV, and you'd hear a phone call go through, but it would be very quiet. This is an 80-line system, and this is a TPL central office. The Stroger systems and the crossbar systems, for the most part, were TPS, which was called terminal per station. Well, this is terminal per line. What that means is you have 10 parties on one line, and it cannot be changed. So in a community such as where this was located, there was 80 telephone lines, and each line had 10 numbers, which would be 800 numbers. Well, in the normal configuration of a telephone office, everything's been issued in thousands group, because out of a prefix you have 10,000 numbers, and this machine prefix is 448, and there's 1,000 numbers coming into it, even though 200 of them go to intercept because there's nothing to physically connect them to. The remaining 800 numbers appear on the line relays. We will make a call through this. This is a link circuit, so all of this equipment right here in one vertical row is one single link. So in this particular half of the cabinet is 4 links. These are the line relays, and then up here at the top is common control relays. The tones that the North Electric machine, this particular one, which was manufactured in 1957, uses a vacuum tube in order to produce the continuous tone for dial tone, and then it has a RC type circuit in it for the interrupter to provide the fairly close to 60 and 120 IPM interruptions that you would have on either vacant levels or a busy line. Alrighty, I dialed one line that I have busy, and of course you hear in the background the busy. Now you hear ringing a different line in the north machine. And this is a 7-digit telephone switch. Normally the CXs were 5-digit or 4-digit depending on the configuration, but this has got on the back of it and a couple of extra relays added in order to be a 7-digit system, and that was done by North Electric. Of course, on the collectors network, this is exchange code 4482XXX is the numbers that come into this machine. I don't currently have any outgoing trunks yet wired to this. I will have in the future. I do have incoming trunks from the outside world into the north machine. Just as a side note, in order to add a trunk, for each group of trunks you lose 10 lines, and so the 1 level and the 0 level is the reason that it's only an 80-line system, because we lost 20 lines for the trunks. The north machine was very sophisticated for its day, but yet it was also limited. It was designed to be in very, very tiny rural areas, as well as this particular type of machine has been installed on military naval ships as the onboard communications. There's been some articles written about that. And the North CX100 is approximately 16 foot long and weighs about 1,400 pounds. We're currently looking at the other half, or the other side of the CX100 basic frame. It is 6 foot long and approximately 6.5 foot tall. This is link 5, 6, and 7, and of course you can tell they're all just duplicated the same thing over and over. This is a North Electric telephone that's mounted in my North Electric system, so I will call that number and it will be ringing it at 20 hertz. I will place one more call and I will select the 50 hertz ringing pattern. We're currently looking at the incoming trunk connector. This has got 6 links in it, so we can have 6 incoming calls from the outside world. In the case of this exchange, we have 4 of them coming in for CNET, which are tandem through my Western step-by-step switch, and then we're going to have 2 reserved, one for the operator and one for busy line verification, which I plan on someday making working. Of the CX100s that I've known about, this is a fairly rare cabinet. Generally, the other exchanges were in such remote areas, they would just use a line circuit to complete a call, which was when they went off Earth, they got dial tone and dialed a 3, 4, or 5-digit number, depending on what was required, and then it would complete the call that way. With my system here, I do have the trunk connector, and this is the only one that of the people who have North Electric machines, I have the only trunk connector that's known about in existence. We're currently looking at the miscellaneous cabinet. This has got the dial tone generator, ringing interrupter, alarming, and miscellaneous type circuits. Up here at the top we have some make busy switches. Then we have the fuses, and then we just have relays for the allotter, group controller, and then we have in here the interrupter, ringing, timing circuit. Down here we have a vacuum tube. This is what's currently used for the tones, dial tone, busy, and so forth. And then more common equipment. Well, this is, I believe, the interrupter. Got it working in the standby. And then there's just other miscellaneous control timing equipment. And then down here towards the bottom was the original trunks that was installed when this machine was in real life service. These will be back working in the future on the outgoing part of the CX machine. Yeah, we're looking at the last two bays. This is the power bay. It has the fusing in it from the central office battery, as well as a test panel. It has a little miniature mainframe test meters. If I had a shoe hooked up to this, which would plug into where the subscriber's line is, I could look at the cable pair. Over on this side we have here and here. These are the vibrator ringing generators. So when the AC power fails, these take DC and produce a 20, 30, 40, 50, and 60 hertz ringing, which is a pulsating DC signal. And of course these only run when there is a line being rung, because these things will run an office battery down very quickly because they're not power efficient. But for 1957 it was what they had for reserve. Down lower, this is under this cover is the relays for transferring between the AC subcycle and the DC ringing, and a few alarm relays and just miscellaneous stuff. This is a K5 subcycle ringing generator, and this has 5 frequencies in it, and I have modified this plant so that the generator is only turned on when I actually are ringing a phone, because this thing here is not power efficient at all, and is quite a load on the AC source. Over in this bay is just some miscellaneous mounted auxiliary equipment that I've collected over the years that fit in a 19-inch rack. We're looking at the master test frame of a Western Electric number 3 crossbar switching system. This is one of 2 remaining crossbar switches, model number 3 that is, that's left in the United States. Western Electric only manufactured 28 of these systems, and this was assembled on a metal frame, wired and tested at the factory, and then trucked to the site that it was going to be serving, the community that it was going to be serving. I have purchased this from Nevada Bell and then relocated it to Oregon, and unfortunately we did not have the ability to move it as one piece, so we had to disassemble the switch and then move it and reassemble it. This has been a very labor-intensive operation to do. At this point, the flashing lights on the master test frame indicates that I have equipment that is temporarily out of service, made busy. The master test frame had the ability to set up calls, monitor calls, and record troubles, such as if there was a failed marker or a register and so forth. It would light up different lights telling you what had failed. It also has the ability to test the trunks locally or make them busy. This was a very sophisticated system for its size. The number 3 crossbar was initially designed as an 800 line machine, and then after 4 or 5 was built, they went back and expanded some of the trunk link frames to allow another 400 lines. Number 3 crossbar being a 1200 line office, 80% of the bays of equipment is common equipment or trunks. So the amount of lines that this could serve took up a relatively small amount of relay rack space in comparison to all of the other auxiliary equipment required to make a crossbar switch work. The number 3 crossbar system's markers are what is referred to as combination markers. which means that they can set up a call for dial tone or complete a call within the system, or set up the proper information needed to complete the call outside of the system. In a normal number 5 crossbar situation, you would have a dial tone marker, and its only function was to provide dial tone or establish the connection for the dial tone, or a completing marker that would complete the call. The number 3, because it was a small office, they had 2 markers so they could do either function. Normally, marker 0, for example, would, when a customer went off hook, would set up a call to give dial tone out of an originating register, and then marker 1 would complete the call when the customer was finished dialing. Of course, either marker can, like I said, either set up a call or complete a call. And if one is made busy, then of course it does both functions. When a subscriber requests dial tone, they go off hook. There's a line relay, of course, like in a step-by-step system. The line equipment requests that the marker complete a call, or set up a call, I should say, to what's called an originating register. The originating register is what provides the dial tone towards the calling subscriber. It records the digits that they have dialed in either touch tone or dial pulse. And at the end of 7 or 10 digits, then the register requests that the marker come in and look at the information and then act on it accordingly. If a call was to be a local call, the marker would then, of course, would ground a code point to indicate that it's a local call, and then it would set up the call within the system on what is called an IAO trunk, and then the customer and the called party would be talking on the IAO. If you was to dial a 1 or a 0, then you would put in the additional information for long distance calls of the operator, and then the register has a couple extra relays to deal with the 1 or 0. And then, of course, at the end of the 7 or 10 digits, it would again request that the marker would come in and look at the information and then act on it accordingly. In this particular system, I have 6 of these originating registers, which means we can have 6 people receiving dial tone and dialing at the same exact time. Of course, this is only for the originating part of the call. If there was a call that was coming into the system, we would be using an incoming register, which will be discussed further on in the video. Alright, in my particular number 3 crossbar system, I have 400 lines. This machine again was initially designed to be 800 lines. Then it was expanded, or the capabilities was to expand it to 1,200 lines. In the office that I bought, it was only equipped as a 400 line office. This number 3 crossbar, and all number 3 crossbars, used what was called CF type crossbar switches. These are a mini crossbar switch. more high density is what the reason for it was. So again, in this particular machine we have line relays, cutoff relays, and lockout relays. In a number 5 crossbar you would not have 3 relays for each line. They would have a line relay, and then the cutoff function was done up on the crossbar switch itself. The number 3 crossbar was designed as a little office, so they didn't need to necessarily reduce the amount of equipment like in a number 5 due to the size of it. And there is a certain amount of economics involved in making a number 3 versus a number 5. And again, this is a 400 line machine. So every single call that is made, the crossbar switches would operate on, either to set up to an originating register, to get you to an intercom trunk, which is referred to as an IAO, or an incoming trunk call. At this point, we're looking at the marker connector relays. These are 30 contact relays. The function for these is when a piece of equipment requests that the marker provide some type of a function, either to complete a call or to give dial tone, you operate certain marker connector relays, which then connects a massive amount of leads between the originating equipment and the marker. Some of these, we may operate 6 or 7 of these relays in one shot in order to provide enough leads to the marker to determine the type of a call and what to do with the call, what it's originating from or terminating from. One thing is, when these relays operate, this is one of the things that draws a tremendous amount of amp load in addition to the marker. One thing about the number 3 crossbar, in my idling state right now, we're drawing about 10 amps of DC power. In order to give dial tone for one customer, it takes about 12 amps for 1 second in order to establish a connection between the line circuit and the originating register. Once the information has been dialed into the originating register, it takes approximately another 12 or so amps for the marker to complete the call, either within the switch or externally. These are the IAOs. These are effectively an intercom, of course, for the number 3 crossbar. So the originating customer would be on one side of the trunk, and the terminating customer would be on the other side. These were only used during an intra-system call. Calls outside of the system would be on a trunk. Incoming calls to the system was on a trunk. So there's a limited number of IAOs. Because it's a 400 line office, they didn't anticipate that many telephone calls. I have, I believe, 30 of them, which of course means you would have 30 local calls at any one given time. These are the incoming and outgoing trunks that was used in the number 3 machine. The original design of the trunks that I have was all E and M type trunking. Thanks to Mr. Steve Flocky, retired engineer, he rebuilt from a circuit standpoint the incoming and the outgoing trunks, drew up a new schematic, and then we actually modified them so that this system could talk to a step-by-step system, either outgoing or incoming. In addition to, I do have some of these that are still E&M connected to the Asterisk system, which then of course is on CNET, and the CNET code for the number 3 crossbar is 543. And I have about 40 of the trunks, 22 to 24 I believe incoming, and then the remaining outgoing to either the step, XY, or other switching systems. The nice thing about the number 3 crossbar is these trunks have an Amphenol connector on the back of them, and you can physically remove one strip to rewire or do maintenance on, modify, and so forth. In a normal crossbar machine, everything was all hardwired, and you had to repair it in the bay where it was actually at. So that was one of the nice features that they had come up with on the number 3 machine. Here is the junctor switches within the number 3 crossbar. Every single call, internal or external, either incoming or outgoing, is completed through these. There are 9 of them in this bay, but we're only showing 3 at this point. This is basically the gateway for every trunk, register, and so forth in the office. So these crossbar switches get the maximum usage of traffic versus some of the other switches because every call has to go in or out or through them. That is, when you request dial tone, the marker completes the path from the line equipment through the junctures to the registers, and of course when you make a call within the system, then we have to switch it to an intercom to IAOs, or if you made a call outside the system, then it has to land on a trunk and then complete the call externally of the system. There is also additional crossbar switches brought into play when a call is being made outside of the system because we have what is called senders, and senders of course will either send MF or DP depending on the office that it is dialing into. And so we have what is called an outgoing sender link frame, and we have also an incoming register link. They're all identical looking crossbar switches. So once you've seen kind of one switch, they're all identical. They just are wired for different functions, and they are located in the switching system in different relay racks. I've included on this a shot of the operator trunks. One thing's kind of interesting is every trunk in the system is a single mounting plate of relays except for the operator. The operator, of course, had the ability to collect and return coins and pay phones, as well as ring the phone back, and there was other functions that the operator could do, and so they ended up using 2 relay plates. So we have in this office several of these operator trunks, but these take up more real estate than the singles, and of course these were probably the least revenue producing of any particular item in the office. We're looking at the ballast lamps in the number 3 crossbar. This system has a lot of ballast lamps in it. Each ballast lamp is in series with either the dial tone, the busy tone, or the ringing within the office. And under normal circumstances, the ballast lamp should never light up. If there was an excessive load or a short, the light would light up, and then I would have to refer to a page in the documentation of the office to tell me what each individual lamp is wired to, and then go to that piece of equipment and try to clear the trouble. So there's a lot of ballast lamps, and they do look like light bulbs, but they're not intended to light up. So it's a good thing to see them not lit up. These Type 70 fuses are in the circuit between a, let's say for example, a dial tone source and a register or a trunk. Unlike in a step-by-step system where the tones are connected from a grounded transformer with one lead to ground and one lead to the equipment with tones superimposed on it. In the crossbar system, they superimpose the tone onto the negative 48-volt battery system. The reason for that was if a trunk or auxiliary piece of equipment, such as an originating register, was to develop problem, it would blow the Type 70 fuse, and then it would isolate that piece of equipment from the rest of the tone source in the office. In a step-by-step, if you was to ground the dial tone lead at a first selector shelf, you would affect most of the central office for at least the dial tone segment of the plant, ringing plant. Here, you would only, in the crossbar system, you would only operate a fuse. This was a pretty neat idea. One of the things that was an education for me is because I'm running this entire crossbar switch off of my Western step plant, is I had to build some circuits to interface the crossbar to the step and to invert the ground source into a battery source. So these particular fuses we're looking at would have busy tone, dial tone, or reorder tone superimposed on top of a 48-volt source. If a piece of equipment was to develop a trouble and blow a fuse, it would light up its associated light, letting the craft people know that there was a issue in the office. And every single fuse is recorded on a chart, so whatever fuse was to blow, you'd have to find out what it was wired to and clear the trouble at that piece of equipment. These are the slave relays that's working off of the motor interrupter in the central office. We have the 60 and 120 IPM, so we have the 120 here and the 60 here. These relays are opening and closing leads and also interrupting a continuous tone to provide a busy or reorder tone. And there's also timing stuff in the office that needs a pulse for like a charge condition on an answered call if it was a message rate circuit, which this office does have the ability to do message rate service, and so we would be using pulses for that. The number 3 crossbar, like the 5 crossbar, has what's called a local number translator. The function of a local number translator is to take the directory number, or the telephone number, and convert it to line equipment. In a crossbar system, the telephone number does not directly correspond to a line equipment number. It has to be associated. So you can have any telephone number wired within reason to any line equipment number. Also, for outgoing calls, such as toll calls, the system also has to have line equipment number to directory number so that it can put that information into the sender and then send it off to the toll office. So the LNT does two functions. So internal calls or external calls into the office, they look for the phone number to what equipment it's wired to, and then on originating calls from the crossbar to the world, then it looks at the line equipment number to determine the phone number. There are 2 LNTs in this particular office. Each LNT's got 300 phone numbers on it, at least in the number 3 crossbar. So I have 400 lines, but I have a total of 600 numbers. So the number 3 crossbar was originally designed for 2-party service or 4-party service. So someday I may try to wire up a multi-party phone line in the office. Where this was installed, they did not use any of the multi-party features. This is the incoming register. A normal number 5 crossbar would have a larger incoming register, which would have more relays for digits incoming, because in like a number 5 crossbar you would have up to 10,000 telephone numbers. The number 3 crossbar system, since it's only got up to 1,200 numbers, we're only using a very small percentage of a prefix. So this was designed to be a 5-digit or a 4-digit register for incoming calls. Now this register has the ability to receive dial pulse, or wired in conjunction with it is a multi-frequency receiver. On an incoming call, it is only going to look for 4 to 5 digits. If I was in my step-by-step system calling into this, then of course I would be sending 4 digits. The number 3 machine originally was wired with 2 office codes. So it was a 20,000 telephone number switch, but it only had the ability to handle 400 actual telephone numbers. From what I read in the wiring information, is Nevada Bell had some stations connected off of this machine that was along highways or mountaintops, and they wanted it to have a different prefix for billing reasons. So they ended up having, I think it was 10 or so numbers out of the second group, 10,000 numbers used. So you had a lot of stuff going to intercept. One thing about the number 3 crossbar, if it cannot complete a call to a line equipment, then it completes it to an intercept trunk, which had a 7A intercept announcer on it. These are the multi-frequency receivers that are wired to the incoming registers. I have 4 incoming registers in the office, and there are 6 multi-freq receivers here. One of these is not wired to anything. The other multi-frequency receiver is wired to the master test frame. So this office had 100% of the trunks were either capable of MF or DP, which was unusual. In the number 5 crossbar, you would have trunk groups that were only MF or only dial pulse. But again, due to the size of the office, they made a lot of this stuff combination, so you could either have MF or DP. Number 5 crossbar has the ability for revertive pulsing, and the number 3 did not have that ever incorporated into it. Revertive pulsing was what was used to talk to panel switching systems, and when the number 3 crossbar was made, there may have only been 2 or 3 panel systems left in operation in the United States, so they did not make any provisions to talk to a panel switch. We're zoomed into what is called a sender. Whenever a call is made that is external to the crossbar switching system, the marker determines through a route relay the trunk group and also the type of trunk that it's being connected to, such as a MF trunk or a dial pulse trunk. When you call from a crossbar switch into a step-by-step, you need to have what is called a dial pulse trunk, because the step-by-step does not have the ability to deal with multi-frequency. If you was to make a 1+ call to outside the crossbar, your call would be completed through a tandem switch, and this office would send the number you dialed and the number you're calling from, both in multi-frequency. So these senders can do one of 2 functions, actually 3. They can send on an EAS basis an MF call, a dial pulse call, or a camera call. If you was to dial 911 for an example, it would land on an MF trunk and would then send the number that you're calling from, but it would not dial 911. You would have a dedicated trunk. Of course, it could send a number if needed to in that particular case. If you dial 0 and a 10-digit phone number, of course, the originating register receives all of the digits. At the end of the 7th or 10th digit, the marker comes in, looks in a route relay, which is 20 route relays within the number 3 crossbar system, determines that it needs to be set up on a trunk, which is an operator trunk, to the TSPS office, and then it would send the number you dialed as well as the number you're calling from. That would be done in multi-frequency. The call I just made was sent out into the step-by-step as dial pulse. You have pulse generators that is effectively creating the same type of a pulse that a rotary dial telephone would send. During that entire sequence of operation, it sent 4 digits into the step-by-step system. I was fortunate enough to acquire some recorded announcement systems that were installed in number 1 and 1A ESS offices. The last generation of recorded announcement that Western Electric made for the 1A machine was the 13A. This is a multi-channel recorded announcement. This message is recorded on what was called bubble memory, which was an early solid-state type of memory. So as long as the 13A was powered up, and in a central office it would always be powered up, then whatever message on the card would be played. Of course, when you removed the power, you lost the message on the card. They did have a battery on the card that you could take the card out and plug another one in or swap them around within the channels and not lose the message, but it was a short-term solution to a long-term problem of taking power off of it. The next system here is a 6A. This is a 6-channel drum. The drum rotates 24 hours a day, 7 days a week, and depending on the channel needed or the announcement needed, the ESS had banks and banks of trunks, and through a amplifier distribution bridge you would have maybe 10 trunks saying the number you reached has been changed or disconnected. Here we have 6 different channels, so I don't know what is on that. I have not actually powered it up to listen to the channels, but whatever was on it when it was installed and working is still there. I do intend on actually powering this up someday and using it, because I think it's kind of neat to have. The 13A is quite an expensive device to run because it's not power efficient. It's some of the early solid-state technology that was, kind of a pig on the electric bill, in my opinion. This is the original ring and tone plant that was built with number 3 crossbar. This system, it produces precise busy, precise dial tone, and precise ringback tone. The same as you would find in today's modern switching system. This is using solid-state technology to drive relays. With this particular ring and tone plant in the idling mode draws 11 amps by itself. Because I'm paying the electric bill to run this thing, this was to me an expense that could be done away with. So I electrically replaced this with relays operating off of my Western Electric step-by-step ring and tone plant. I do intend on providing one small tone source to provide a different busy and busy tone and dial tone to the crossbar, so it won't be the same as the step-by-step. But this system was used in what was called a 5A crossbar as well as the number 3 crossbar system. And it was one of the last ring and tone plants that Western Electric designed. Interesting enough is this is designed by Western but actually built by Lorraine. This is the Western Electric CDM that was built with the number 3 crossbar. It's a miniature cosmic frame, the same similar design as a regular cosmic frame, except the blocks in a normal cosmic frame would be yellow or blue. These are heat coils for each of the subscriber lines, so there's 100 potential phone lines here going off to the businesses or community, residential people in the community. So you would run a cross connect between the line equipment and the protector frame, and then also you had trunks. You could go between the trunk and the protector as well. This is unique that this is the smallest cosmic frame I've ever seen in my lifetime, and it was a neat idea. It kept all of the jumpers very short and very neat, and of course this was standard with the number 3. This is a model 3CL toll switchboard, manufactured in 1957, this particular segment of switchboard. This is primarily used for operator-assisted calls, 1+ calls originating out of a step-by-step central office or a crossbar central office, as well as the independent telephone companies. When a subscriber dials 0, they would come into a jack on the board. This particular switchboard was in Portland, Oregon, and has locations for Oregon and Southwest Washington on it, which this board was in service until the mid-80s when they finally retired it, because it was dealing with the IMTS, MTS, as well as the ring downs, toll stations, and so forth. On this switchboard we have, of course, the cord pairs. You have the front cord and the rear cord. And then you have the keys to operate to even talk to either the front cord or the rear cord, as well as ring the front or the rear. And the operator could either bridge in or have the line split so they could talk to either party independently. Here's a close-up of the key shelf when I put it back to as close to original as I could, showing the DC buttons, which will provide DC signals to a DC key pulse sender, which then will take the DC signals and convert it to rotary dial to dial into a step-by-step toll train. As well as we're going to configure this so that we can send MF tones into the Astra system through the tandem jacks, such as they would have in the original days. Here's a close-up of the key shelf with the lever keys with the orange handles, which was the ringing to the front cord or the rear cord, and then the lever keys with the black handles, which for the operator could talk to the front cord or the rear cord independently. Also, next to it is an IBM keypad that was the last evolution of mechanized billing that Pacific Northwest Bell utilized in Oregon and Washington. This connected to an IBM computer, and the information was keyed in to the computer so that it would keep track of the calls instead of doing it on paper. The tandem jacks here would be connected to typically a number 4 type toll machine, such as a 4A, 4M, or in some cases a number 4 ESS with the proper trunks. The lights would light up on the cords when a subscriber hook switch flashed or to recall the operator, and at that time the operator would either disconnect both cords or talk to the subscriber. This particular device here is a coculograph, which is not the correct one for this particular segment of switchboard, but the operator would take a card at the beginning of the call, punch it in would put it in the coculograph, punch it, and then would put it in a slot, which is right next to the cord circuit. At the end of the call, they would take the card and put it back into the device, punch it again, and then that would go off to the billing office, so they would take the start time, the end time, and calculate out what the duration of the call was. This particular switchboard here, of course, is 4317, 4316. I believe, from my information, there was about 100 of these positions in the office that this was in. And at one time, of course, every jack and lamp was utilized. Here is a close-up of some of the labeling above the jacks that shows the Portland MK221, which was the MTS radio telephone system. Here is a close-up of the Hoodoo toll stations as they were prior to 1995 when they were removed. The Hoodoo is a ski lodge on U.S. Highway 22 heading from Salem, Oregon to Bend, Oregon, or from Portland to Bend. And you can see there were several other locations. This switchboard was left operational to handle all of the non-mechanized type calls, such as the IMTS, MTS, toll stations, ring downs, and things that was not cost effective to put into the TSPS modern systems. This switchboard was retired, I believe, in 1987. Here we show the exchange of 433 Marcola, Oregon flat rate and prepay pay telephones. Marcola was a population of approximately 400 subscribers in its original day. This is the rear of the 3CL board. I have not completed any of the wiring yet, so it's kind of a mess. This is the position circuit. It has the relays for the cord circuits and control. The test board closest to the wall by the 6-button wall phone is a number 17 toll test board. The center test board is a number 18 toll test board. The last closest test board is a number 24 private line test board. The number 24 test board has the ability to send MF, DP, or DTMF from its key set. The number 17 and number 18 can function as a DC or MF key set. All three of these test boards are 9 foot tall. The total length is 7 foot from left to right.